In this section, we look at how to use parentheses, and we look at ways parentheses are abused. But remember these: 1% is equal to 1 over 100. P% equals P over 100. So like 4.2% is 4.2 over 100. And when you use your calculator to do this last one, it'll move the decimal to the left 2 places for you. So percentage just means to divide by 100. That's it. Now the word of will have special meaning when we're dealing with parentheses. Percentages. Of will mean times. Multiplication. Here's an example to illustrate the of. You can see that it's right there. So we're going to take 64% times 1069. Now, it's almost certain that you're going to want to change this to a decimal instead of that. So we're going to have 0.64 times 1069. Let me pull out the calculator. 0.64 times 1069, 684.16. So most likely, if we're talking about the number of people, then it's most likely that there were 684 people. And then when you took the percentage of that, it rounded up to like, it probably rounded like 63.9% and rounded up to 64%. The next topic is percentage change. So as an example, we would say the number of people who live in a certain town increased from 10,000 to 15,000 people. So we want to know what was the percentage increase. So the way the formula works is your book refers to this as relative change, so I'll use the same terminology. I personally like to call it percentage change. So the formula goes like this. You have the new value minus the old value, divided by the old value, because you're comparing the new value with the old value, and then finally multiply by 100%. So let's use that in this example here. So the new value is 15,000, and the old value is 10,000, and we're going to divide by the old value, which is 10,000. And then to make it a percentage, we're going to multiply by 100%. Remember that 100% is no different than the number 1. So we can add it, we can multiply by it, or divide by it, and it doesn't change the value of anything. What you're going to find here after you do this is we get 0.5 times 100%. And that, of course, is 50%. This should make sense to you because it increased by 500, which is exactly half of its original value. So it put half of its original value as growth. Here's a problem that just is going to use the formula that we just developed. They want to know the absolute change and the relative change for a stock that went from $7 to $14. Now, if you look, this stock started at $7 and doubled to $14. That means it added $7 to its own value. That means it added 100% of its own value to itself. Let me get these things. The absolute change this is just the larger or the new minus the old. And that's just $7. Now, the relative change well, the new value is $14. The old value was $7. The old value was $7, and then I'll multiply by 100%. When you do all of this in here, you're going to get 7 over 7. In other words, you're going to get 1 times 100%, which is 100%. A certain stock plunged in value from $20 to $5. Compute the absolute and relative change. So the absolute change take the new value and subtract the old value from it. This equals negative $15. And the relative change will tell us the percentage that it has decreased in value. So the new value is $5 minus the old value divided by the old value times 100%. I think you'll find that this turns out to be negative 75%. And the negative is used to indicate that the stock value decreased as time went on. So the absolute change is the ending amount, which was 7.9 billion minus 2.6 billion. This is 5.3 billion. And the relative change that equals 7.9 billion minus 2.6 billion divided by 2.6 billion times 100%. Let me pull out the calculator for this one. The billions will all cancel out. It's just part of the work. So I'm going to ignore those while I do the work. I'm going to do 7.9 minus 2.6. So you see the top of this fraction, or the numerator, is actually just the absolute change. When I divide it by 2.6, I'm comparing it to 2.6. And then multiply by 100%. And I'll just round to one decimal place. It looks like I'm going to get 203.8%. So you see, it increased by more than double its own value. So if you take 2.6 and multiply it by 2, that's double its value, that'll be 5.2. Now if you take the 5.2 and add it to 2.6, you almost get to 7.9. That's why it's a little bit over 200%. Here's an example where you bought a computer that's gone down in value. So we'll take a look at the absolute and relative change. It was $1,000. Today's value is $300, so it's gone down in value. So the absolute change that's going to be the 1,000 minus 300. Sorry, I have it backwards. 300 is the new value minus the old value. And that's negative $700. Now you could probably do the next part easily. That's 70% of the entire value of the original value of the computer. So the next one will give me negative 70% will be the relative change. You'll see. So the new value, $300. The old value was $1,000. The old value, $1,000. And then I've got to multiply this by 100%. So you'll get negative 0.7 times 100%, which is negative 70%. A Mercedes costs $50,000. And a Lexus costs, let's say, $40,000. How much more as a percentage does the Mercedes cost than the Lexus? So all we have to do with this then is look at a relative change. Since we're comparing it with the Lexus, I'm going to say that the Mercedes is the new value and the Lexus is the old value. So since the comparison is directly with the Lexus, we're going to put the Lexus value in the denominator. Here's $40,000 times 100%. Now keep in mind that all these dollar signs will cancel out in the mathematics that is done. What we end up with inside of here is we have 10,000 over 40,000. In other words, we end up with 0.25 times 100%, or 25%. So we can say that the Mercedes costs 25% more than the Lexus. So that was when we were using the Lexus as our reference. Now if I switch things, I could say how much less as a percentage is the cost of a Lexus to a Mercedes. So this time how much less as a percentage is the cost of the Lexus than a Mercedes? So I'm comparing it with the Mercedes this time. So when I do my relative change, I'm going to put the Lexus first and the Mercedes second. So now when I do it, I'm going to end up with negative 0.2 times 100%, which is negative 20%. So the Lexus is 20% less than the Mercedes. This is another example where you compare one thing to another and then you reverse that comparison. So here we have the highest ranked state in the country has a wage of about $86,700 per person, and that is in Maryland. In Mississippi, they're ranked last at $45,800. So my first question is, how much lower was average income in Mississippi than in Maryland? So than in Maryland means I'm comparing it to Maryland. So with part A, if we look at the absolute change, it asks for this as part of the problem, but you don't need to do that for the percentage change. The absolute change, since we're comparing it to Maryland, we're going to take the Mississippi first, which is $45,800, and we're going to subtract $86,700. And that looks like $40,900, but negative. Let me just check with my calculator. So I got my negative 40,900. Now, if I want the relative change, we're comparing it against the Maryland rates. It's got $45,800 minus $86,700 divided by $86,700 and then multiplied by 100%. Now I've already done the top part, so let me divide by the denominator. So we will divide this by 86,700, and then I'll multiply by 100 to give me a percentage. I'll say 47.17. I'll just round to one decimal place. Negative 47.2%. So we could say the average wage for a Mississippian is less than 47.2% less than the average Marylander. Now if we reverse this, now we're looking at how much higher the pay is in Maryland versus Mississippi. Here we're comparing it with Mississippi. So the absolute change, the only thing that's going to be different here is that the bigger number is going to come first because the comparison is the one that you put second. So we're going to have 86,700 minus 45,800, and this is 40,900. That number will not change, but the relative change will be different. Because now you're comparing to Mississippi's wage. So we're going to take Maryland, 86,700, and subtract the Mississippi wage. I think that was 45,800. I got to be a little careful here. And we're going to divide by 45,800 and then multiply it by 100%. See, this part down here tells you what it's being compared with. So let me go back to my calculator. I'll start with my 40,900 again. This time I'll divide by 45,800 and multiply by 100%. It looks like 89.3. So Marylanders, on average, are paid 89.3% more than Mississippians are paid. Of versus more than. They're related to each other, but they don't, of course, say the same thing. We already know of means multiplication. So let's take a look at something here. 600 is a what percent increase from 200? Oh, I'm just doing 200. It's not dollars, just 200. So think about this. The increase is 400. That 400 is twice the 200. So what we do there is we can convert from more than to of in the following fashion. So we're going to take our relative change, and we're going to have 600 minus 200 over 200 times 100% equals 300%. That's one way to do it. Another way to do that 300% is the following. When we increase, suppose we increase a quantity X by P%, then we now have 100 plus P% of X. And that of means multiplication. So if I know the increase here is, I told you the increase here was 200% increase, going from 200 to 600. 600 is 200% more than 200. But then I can also get it to do it this way by saying 100 plus 200% equals 300%. And then when you take your 300% and multiply it back by the original, you'll get 600. The Earth's average density is 5.5 grams per cubic centimeter. The density of Mars, the average density of Mars, is 0.7 grams per centimeters cubed. Now, when I take then 5.5 and divide it by 0.7, let's get that calculator. That's roughly 7.9. So this is roughly 7.9. What I can say with this is I can say that the average density on Earth is 7.9 times that of Mars. But in the same way, notice I'm comparing with Mars, so Mars was on the bottom. In the same way, I can do the comparison the other way. Let me have my calculator pull that one out. Now we're going to take 0.7 and divide by 5.5. And it looks like we got 0.13. So 0.13. This means that the density on Mars is 0.13 of Earth's. In this example, we're told that Jada makes 200% more than Reggie. They're not saying that Jada makes 200% of what Reggie's paid. She makes 200% more than Reggie. That means we can get Jada's pay, her income, in the following fashion. I'll use J for Jada. So I can have Jada. She makes as much as Reggie does, but then she makes twice as much as him more, for a total of 3R. Well, that's 300% of R. In other words, that's 300% times R. So we could say that Jada's income is 300% of R's. Here we're having a 25% off sale. So the new price of something will look like this. You'll take the original price and you'll subtract 25% of the price from it. Now I'm going to use the distributive property to factor out a P. And I'm changing the 25% to a decimal at the same time. 1 minus 0.25 is 0.75 times P. So this is what we'll do to find the price. So what we see is that the new price is 75% of the original price. A bank increases a mortgage rate from 3% to 4%. What is the relative change? So by what percentage did it change in value? So we do the formula. We take the new minus the old and divide by the old and then multiply by 100%. Mathematically, all of these percentages inside here on the fractions will cancel out, and then you'll gain the percentage here. What we'll end up with then is, if you use your calculator to get this to I'm going to go 4 decimal places, even though the 3's go on forever. I think you'll find that this is 33.33%. That's how big of an increase it was. It's 33.33% more than what it used to be. This problem tells us how landline usage has fallen in this country. It used to have 90% of households had a landline in 2004 compared to just 39% in 2020. So the new value is 39%, the old value is 90%. So when we look at the absolute change, we're going to take our new value, 39%, and subtract our old value. That's negative 51%. And then the relative change, we're going to have 39% minus 90% divided by 90% times 100%. We go ahead and pull out the calculator for this. If you're doing it on your calculator, make sure you hit enter before you do a division. Now I'll divide that by 90. And then I'll multiply by 100%. Looks like negative 56.7% roughly. So landline usage has fallen almost 57% in the last 16 years. All right, some of these examples are just to get you comfortable with how things are phrased. Here, we're assuming that 40% of registered voters in Carson City are Republicans. So let's take a look at the A and B and see what they have to do with Carson City's voters. In Part A, it says the percentage of voters registered as Republicans is 25% higher than in Freetown than in Carson City. So they have 25% higher. So what they did is they started with 40% and then they added 25% more. So the distributor property could have taken care of this real easily. We have 40% times 100 plus 25%. And I think you'll find out that this turns out to be 50%. And that should make sense. If we take 25% of 40 equals 10%, take the 10% and add it to the 40 to give you the 50, and you'll see you get the same thing. This is a little bit different. 25 percentage points higher means this is what you want to do. You want to take your 40% and then directly add 25% to it to get 65%. Let's say retail prices are 25% more than wholesale prices. So if we use R for retail and W for wholesale, here's what we have. I can get a retail price by taking 100% plus 25 and multiplying it to the wholesale price. So if for example, if W equals, let's say, $10, that's how much it is for a dozen of eggs, for example, $10. Then the retail price will look like this. We'll have 100 plus 25. So this 100 just doesn't do anything. That's equal to 1 when you're talking about a percent. Remember, this is a percent. Now this is actually adding something, so we are increasing the value here. And W is our wholesale price. So let me put it in terms of decimals and what W is. This is simply going to be 1.25, and the W equals 10. And you'll see that this equals $12.50. Here, these are sales tax problems. In Part A, you purchase a t-shirt with a labeled pre-tax price of $17, and the sales tax is 5%. So what's your final cost? I'll just do these in order. A. So what we're going to have is we're going to have $17, but we're going to have 5% of that same amount, and that's going to be the total that you pay. So this piece here is the tax amount. Now you might find it very useful to factor out the $17, and what you're left with, so I got two factors. I've got a factor from here and a factor from here. When I factor it out, factor out the 17 from itself, we're left with a 1. And if I factor it out from that piece and change it to a decimal, I have 0.05. Well, that's just $17 times 1.05. Then I can get the total cost with taxes included by just doing this one calculation. You can use your calculator to find out that this will be $17.85 after taxes. In Part B, you know what you paid after taxes, and you know that the taxes that you paid was 7%. So using this idea right here, we know that 17 times, I don't know the original price. Sorry, let me get that out there. I know that I bought something. It cost some sort of a price, but then when I added 7% of its own value to it, which is this 1.07, the 1 maintains its value, and the 0.07 in this case does the increasing part of it. And we know that this is equal to 19.26. We're told the price afterwards. Divide by 1.07, divide by 1.07. Comes out to 18. Nice answer. 18, in fact, dollars. And finally, Part C. Here, you are eligible for a 15% discount. So instead of adding 0.15, you're going to subtract it. So we have $55 as the normal cost. That's the normal 100% cost, but we're going to subtract 0. We're going to subtract 15% from it. Or if I convert everything to decimals, let me do that instead. So there's the taking of the 15% away. And then if you want to do it all in one computation, you do 55 times 0.85. And let me go ahead and grab the calculator for that. So the new price looks like 46.75. Here's an example where a percentage is changing. So we have the market share for electric cars this year compared to last year is up 43%, and the new value is 4.2%. What was the market share before last year? So it's up 43%. So what we do is this. We would like to know what our price was last year. So I'm going to take P, and I'm going to take 1 plus 0.43. That's the increase. And that's the decimal version of it. And we know that that has to turn out to be 4.2%. So let me convert everything to decimals. 0.042 is the right side. The left side is P times 1.43. Let me divide both sides by 1.43. And that gives me 0.042. 0.0294. I think I'll do that many decimals. 0.0294. And then it says what was the market share, which is a percentage. Notice that we're at 4.2% this year. What percentage was it last year? If I take this decimal and convert it, it had 2.94% of the market last year. In this problem, we're just trying to figure out if the stockbroker is telling us the truth or not. He says that I admit that the value of your investments fell 60% during the first year on the job. However, this year the value has increased by 75%. So you are now 15% ahead. Let's evaluate the idea. So let's start with $100. All right, now the first thing he did is he lost 60%. So we take the $100, we multiply it by 1 minus 0.60. And you'll find that that equals $40. That was after the first year. Now for the second year, you take that amount, this $40, and you're going to increase it by 75%. So we're going to multiply it by 1 plus 0.75. I think you'll find that this comes out $70. The stockbroker is completely wrong because he says you're 15% ahead. You put $100 in initially. You don't have $115 here. You only have $70. You've come out 30% below. So he's absolutely lying, or he doesn't know how to do arithmetic. So there's a politician that says he can save you 20% each year for the next 3 years, and just adding them up figures that's a 60% savings. Let's try the same thing as before with starting with $100. Suppose I have a tax bill of $100. The first year he cuts it by 20%. So in the first year, we're going to take our $100 and multiply it by 1 minus 0.20. I think you'll find that that comes out to be $80. Now, it's that number that we're going to take and put the 20% decrease to the next year. So I'm going to take my $80 and multiply it by 1 minus 0.20. So at the end of the second year, I think you'll find that this comes out to $64. And then finally, in the third year, we're going to do another 20%. And let me just put my 64. You can accomplish the same thing by simply taking 64 and multiplying it by 0.8. That's 51.2. $51.20. Now, if it were true that the total cut was 60%, then of $100, you should only be paying take the original amount, take 1 minus 0.60, and I think you'll see that you should be paying $40 after the third year if he was correct. Instead, his total amount that he's just decreased taxes, it looks like 48.8% was the total amount that he decreased taxes by. Here we have a baseball player who, in 1 year, the first half of the year, the batting average was 200. Pretty low for a baseball player. But the second half of the season, they were at 400. And so it says, can we conclude that the player had an average of 300? That means if we just average the 200 and 400 averages, would that come out to 300? And the answer is no. It depends on the number of times they were at bat. So a 200 average is low, so it's kind of possible that playing that poorly might have reduced the number of at-bats. So let's just say that he had 100 at-bats. I'll call it A, B, and that was at a 0.200 average. That means that 200 out of 1,000 times they hit the ball. Or another way of looking at it is they hit the ball 20% of the times they swing the bat. Second half. Now, a batting average of 400 is very high. So it's quite possible that he would have played more at-bats. So, here, if he batted 20% out of 100 at-bats, that means that he got a total of 20 hits here. But now over here, 40% of 200 is 80 hits. So he has a total of 80 hits, a total of 80 plus 20, which is 100 hits, out of a total of 100 plus 200 at bats. So his number is I'm going to go 4 places. 0.3333 is his average, which is not equal to 0.3. So it depends on if it would have worked out had he batted the exact same number of bats in the second half as in the first half.